Alrighty, maybe we'll get things started here. Welcome to all of you. Thanks for coming in. Looking at system modernization and different justifications and potential approaches. I'm Varun Khanna. I manage the Gerrie process group, and I've been in that role for about a year now and have had a few different roles across different industry sectors over the past 20 some odd years, ranging from integration across oil and gas and wastewater, power generation, all that kind of thing. And with me today, we've got Robert Poweska.
Yeah, I'm Robert Poweska from ArcelorMittal here in Hamilton. I've been around control systems for more than 20 years, across various industries, high-speed packaging, steel mills, copper mills, so kind of seen it all and heard it all.
Alrighty, just as a quick overview of what we're going to be getting into today. First of all, clarify a few terms. I'm sure a lot of folks have heard about modernization, heard about migration, things like that. So just to clarify, for the purposes of what we're talking about, what we're referring to when we talk about migration versus modernization. Some ideas and thoughts on when to consider modernizations, what some of the challenges might end up being, and then those will kind of roll into what are the things that drive the modernization projects, and eventually, when you combine it with the approach and some of the risk profiles, to be able to build that business case and that ROI that folks can either, depending on which side of the desk you're sitting on, if you're on the end user side, whether you can go in and get capital approval for those kinds of things, whether you're on the integrator, OEM, or the other side of the table where you can make that justification for performing that service as well. And then we're going to go through a couple of examples that we've got as some of the projects that Robert's been working on over at ArcelorMittal. So, for the purposes of what we're discussing here today, migration is basically just updating your system to a modern platform. And a lot of times we look at that from the perspective of saying, all I'm going to do is I want to take my existing application and move it up to whatever the current version is of the operating system, the software, communication protocols, things like that, and let it run as is with all the existing bits and pieces. Whereas if we take a look at the modernization, really what we want to be able to do is take a look at the function of what the legacy system is doing and be able to say, how would I best implement that with a modern platform? How would I be able to take advantage of some of the modern features, the communication protocols, and some of the other technologies that are available? You know, obviously, a great example of that would be in the keynote session where they kind of went into the Thin Manager to be able to look at different ways of doing that. Although I've been using Thin Manager for about 10 to 15 years, prior to that, there was really nothing like that. Wouldn't have been possible to be able to do those kinds of things without putting in a lot of work and effort. It's also an opportunity to go through and take a look and improve what the plant operations are, to improve that deployment of the controls within that plant environment. Is there a better way for operators to interact with the controls? Is there a better way for controls to interact with the process? And is it providing the information and the reporting that is required? And is it simplifying all of that? So really, the effective modernization requires a bit of a plan, and it is part of that overall asset modernization lifecycle. And very often, that plan includes doing an assessment up front to be able to say, hey, let me get the best understanding I have of what the system is in place right now, so that we understand what each of the functions are, so that whether, as you'll see later on, whether I'm going to rip the whole thing out and just replace it fresh with a new system, how does that system have to work? Whether I'm going to phase it in and do it in pieces and perhaps do the visualization first and do controllers later, or whether you actually have to get to the point of saying, you know what, this is such a critical operation in my plant, I need to be able to move that over on a loop-by-loop basis. And sure, it might take a little bit of time. Maybe you do 1 or 2 loops a day, and it lasts over the course of perhaps a year or 18 months to be able to complete that transition process. So, some considerations. When would I want to look at that modernization? And there's a lot of different things that are involved, and not all of these points will apply to every industry or every role, I'm sure, that's represented in the room. But certainly, do you see production costs rising because you need to be able to change, you need to be flexible and agile? Is it something where perhaps through customer demand or through consolidation of plants, I need to be able to change the product that I'm running on a given line or through a given plant? Things like, is there inconsistency on the quality end of things that we need to be able to improve those sides of things? Are there issues with respect to raw materials or finished product or intermediate products that either sit for a while because the process isn't ready? Maybe that is one of the causes of quality issues down the road. So there's lots of different things there. One of the big things that I tend to find is also, can that plant floor system connect to our ERP system? Can it connect to the business systems that we have so that we can see in near real time what is happening on the plant floor and be able to interpret that back into some financials? And the financial folks want to be able to make that forecast to be able to say, here's what we anticipate production might be on a day-to-day basis, week-to-week basis, or whatever the period is they need to be able to forecast for. And one of the big things also becomes, what are those customer demands? A lot of them tend to change. Some folks may ask for specialized products. Some might have, perhaps not the product specialized, but I need it packaged in a certain way. Maybe it has to do with specific quality specifications. All those kinds of things kind of lead back to that flexibility and agility that folks want in their systems. And as technology advances and as we are able to capitalize on those technology advances, then we are able to more easily provide those to the customer. It doesn't have to do with not being able to or not being able to, but how easy is it from the end user perspective to be able to make those changes and to be able to change on the fly. So, as with everything else, there are challenges that are in place with maintaining and advancing through this life cycle, and there are costs that are associated with that. Obviously, a big part of it is the first point: hardware, software, networking. I have 3 different vendors worth of control products across 3 lines in my plant. How do I consolidate all of that data into one spot to be able to more easily and effectively calculate what my line efficiency is, for example? How do I go through that if I have three different vendors? How do I present that in one piece of visualization? How do I look at network traffic and network communication? Is my network designed and structured and segmented appropriately to be able to use all of that, to be able to say, hey, we want to be able to use, for example, managed switches and be able to define the VLANs and segment out those smaller bits of network to say, you know what, communication doesn't need to go from segment A to segment B. We can isolate those, and therefore it makes the network more efficient overall. Another big one that I tend to see is spare parts, is whether they're on the shelf or they're on the shelf and have been sitting there for 20 years and I don't know whether they're going to smoke when I put them in play, or the fact, go back to the example, I've got 3 different vendors worth of controls equipment across 3 different lines. Well, now I also need to have 3 different rooms full of spare parts to be able to make sure that I can keep my lines up and running at all times. So there's a lot of different challenges in there. Some of these other ones come down to, okay, if I'm doing commissioning, I want to go across the plant, and if I got 3 vendors of controls, do I have people that can do that? Do I have native knowledge, through my staff to be able to manage all that? If something happens on a night shift or on a weekend, do I have the appropriate people with the appropriate knowledge to be able to handle that? And then it goes on to be able to say, there's some other things such as energy usage, floor space, cabinet space, things like that, to say, hey, especially when you get into upgrades and expansions and things like that, well, I have 4 cabinets worth of controls, but I only have 1 cabinet here that's dealing with that particular line, and I can't rip and replace because that's an essential function within my plant, so now what do I do? Where do I physically house that equipment to be able to go through? So there's a lot of different aspects to it. But looking at the modernization overall, there are some benefits, in terms of the modern communication protocols, the modern network designs, the ability to consolidate data and do optimization across the plant and to do comparison between lines, to be able to increase that quality and potentially yield through the line production, and to be able to use other types of infrastructure, whereas in legacy systems, very often you needed to be directly connected. In most of the modern systems, they're either server-based, you have a lot of remote, it can be cloud-based, so there's many different ways, as was demonstrated earlier in the presentation, that staff can interact with that system to ensure that it is kept running. Again, come back to there is easier integration with a lot of the other systems as well, whether it's the business systems, ERP systems, to be able to serve up data across the enterprise, not just to a given plant or even a given line within a plant. So all that kind of rolls up into a series of drivers, and this kind of just illustrates some of the things that we've been talking about along the way. There's flexibility, there's agility. You heard Amy mention the fact that there's a significant part of the population that's thinking about retiring. So you've got some resource loss there. You've got new resources coming in that want to do things in different ways. You want to be able to reduce downtime to deal with system losses, especially with perhaps premium time type, off shift type outages if you're not a 24/7 operation. Sometimes you deal with parts availability. A big one that's coming up is that combined IT/OT cybersecurity posture that a lot of companies are starting to look at now. And should that sit on the IT side? Should it sit on the OT side? Should it sit somewhere in the middle? Many companies are having that discussion. Some have decided to throw it to one side of the fence or the other. No real right answer, but as long as all of the different vulnerabilities are assessed and have been addressed within that posture. And then there has to do with the system limitations. With legacy control protocols and systems, there was always limitations as to how many devices, how much remote I/O, how many different third-party devices can I communicate with. There's certainly with respect to memory and programming capacity, things like that. Whereas with modernization, there's a lot of the techniques that help to alleviate what some of those are. All of it driving back to flexibility and agility. So if we combine those all with a couple of different approaches to it, we talked about rip and replace, which is sometimes nice to be able to do, very clean, typically lower cost than most, but also requires a lot of downtime. And it requires an extended shutdown, which is not always possible. In those particular cases, you got to look at something else. So you go to something, either a phased approach or a shadowing type approach, where your risk comes down. You're able to do things potentially while you're online by just doing partial shutdowns to the operation, but the cost goes up because the project gets extended. There might be more people involved. There may be temporary measures that you have to implement in between to ensure worker safety, to ensure that the shutdown is contained and the work that you're doing is contained to a certain area. And so therefore, obviously shadowing being probably the least risky but the most expensive to be able to actually fully implement the system and actually have it working alongside the legacy system to determine its functionality prior to bringing it over live, whether you do it on a loop-by-loop basis, whether you do it on a system-by-system basis, meaning plant system, or a system-by-system basis based on control system. Maybe I want to say, hey, I want to replace my HMIs first. Do the visualization portion. Okay, that gets all taken care of, but you still have legacy controllers underlying all of that. Maybe you decide to go through and say, hey, we're going to go through on a controller-by-controller basis and do replacement from there on in, and then that capital cost can end up getting allocated to different years, And it may be easier to build that business case, or more acceptable to build a business case with a reduced cost that's coming over a longer period of time than one big hit that would come with a rip and replace type project. So just to kind of emphasize it, the risk versus cost, obviously you got the rip and replace, which is probably the least cost but the highest risk, because you never really know what's going to happen when you hit the start button. You've got the phased approach where you've got less risk because you're only doing a piece at a time. And so therefore you've got a little bit of time to make sure that things are going to be working properly and that things are effective before moving on. And you've got shadowing, which is probably the least risky and the most amount of cost, where you actually have the new control system and the legacy control system working side by side before you actually continue with that implementation. Then from there, you can roll all this stuff up to be able to build this business case and this ROI. And a lot of times the business case, I'd love to be able to go up and say, hey, you know what, if you write it like this, it's going to work for you. But I can't do that because each company is different. Each company will have its own issues that it wants to recognize, its own production environment, its own culture. There will have different KPIs or indicators as to how production and people are measured. And that business case needs to be written to be aligned with what those are. If one can demonstrate to the management or decision makers how this replacement, the business case for this replacement, affects those corporate indicators, which would likely in turn reflect upon them, that would be the case to make as to how it would improve that, or how it would make them look better in the long run, how it would help. Perhaps in the short term, it stays constant at worst. And then in the longer term, as systems get implemented, as production increases and quality ramps up because of the implementation of new technology, as procedures are simplified, you can kind of go up from there. But to be able to package all those challenges that we talked about, to take those drivers for modernization, you want that flexibility and agility, all the cost factors and the benefits, and link it back into the goals and performance indicators, both corporately and per business unit, or however the company is divided up, to be able to write that business case and have that justification for the capital dollars. A lot of times, the modernization projects are going to enable a lot of communication exchange, especially when you're looking at integration into business systems. And so therefore, that in turn provides a lot more information up to that business level. It involves the reporting, whether it's the regulatory reporting, whether it's board level reporting, or obviously many different facets of being able to represent that data. And then all the other stakeholders that are involved in the organization, all of their data can be gathered in, whether it's the quality end of things, whether it's the production side, whether it's the raw materials inspection, all of those things can be gathered in to be able to feed data into that reporting as well. And all of that, all of the benefits from the modernization need to be shown to be advancing whatever the company's strategic direction is. If the company has come out and said, hey, you know what, we want to be the forefront and the leaders in implementing modern technology, whatever those words might end up being. Okay, now if you're writing that business case for doing a control system upgrade and a modernization, well, how does that modernization fit into that goal of being a leader in technology implementation? And sometimes it needs to be made very obvious to those decision makers, because they don't always have a hand in the day-to-day operation. And so therefore, it needs to be brought up to their attention. From there, I'd like to hand it over to Robert to kind of go through a couple of examples that they've got that have happened at Arcelor, and go from there.
There we go.
Yeah, you got a pointer there. There you go.
Okay, so I'll take you through a couple examples of what we did and how we utilized the rip and replace approach, phased-in approach, and shadow approach, and a couple of the projects that we've done. And I just realized that this is an example of one of our older screens, and that screen was designed and programmed by my boss, who's in the audience, so I won't be criticizing it too much. But I just wanted kind of to show you what we had, or what we have, and what we kind of go through. So a legacy system uses a lot of colors. Green, red, blue, running, not running. Above this screen, there's an alarm banner. So if I look at this screen, for example, and if I look, let's say this is compressor number 2. It's red because it stopped, but I'm an alarm banner over here. I got a bunch of alarms, they're also in red. So if you grew up with a system like this and this is what you're used to, that's great. But for a lot of new people, especially the younger people coming in, this could be confusing because I have an alarm over here and this is also red. So now, is my machine right or is my machine not right? So we've decided that we're going to utilize the ISA standard and replace the system with the new Rockwell plant packs, virtualize it on virtual servers using thin client technology. So some of the challenges we had, obviously lack of system flexibility. We could only use whatever was defined. To put new graphics on was difficult. You had a dedicated engineering workstation. That's the only spot where you could do any engineering from. Where right now what we moved to is virtual engineering station. We can do it from anywhere in the plant. As a matter of fact, I can do it from home. Our system was running on an antiquated OS system. The water plant that we did years ago was still running on an old DOS-like system. Edits were extremely complex to do. I mean, it took hours to change a range on an I/O, or even to put a new transmitter in and do all the graphics. System was down a lot. We had one guy in our department that actually knew how to run it, and he was just about to retire. We had no plans on training anybody. It was old system installed in the 90s. So we've decided that we're gonna replace it. And the only way to replace a system like this, we couldn't shut down the plant. We had to use a shadow approach, where we had an old TDC 3000 system. And so not only did we replace the HMI, but we also replaced the control system itself, where we had to install new PLCs and run them with tandem with the new system that we were developing. So some features of the new system was flexible. It was user-friendly. We could access it from anywhere. All the plant packs pop-ups, the graphics, runs on a modern OS system. I think we run on Windows Server, 2012. Our IT people were really happy that we got the old system off the network. Using virtualized servers saved a huge amount of time, especially when we had to do patches. And we're in a business unit with utilities. We have plants spread all over the Dofasco. To do patches on 30, 40 computers, it would take a week sometimes. If you have to go to a machine and wait there for 3-4 hours before it finishes, and then once it finishes, you got to do it again because it wants more stuff. Virtualized servers, I mean, you do it in one spot. You do it from your desk. And all the thin clients, I mean, they're just basically a window into the server. Process library, including permissive interlock blocks, very easy for troubleshooting, for operations, to see what's wrong with their system. But multiple systems can be operated from the single interface. I mean, I can do everything from my desk. I can look out on my system. We can utilizing the thin client manager, we can shadow a system, and I can see exactly what the what the operators are looking at. Our signal scaling can be done right from the plant box pop-up. I don't have to go into the PLC and change a range on a transmitter or on a level device. I do it right from the pop-up. Maintenance guys would used to call us if they were working on something to go through the logic, make sure it doesn't shut anything down. Can you bypass this for me? Now with the new plant packs, they just hit the maintenance mode and they can use this function substitute PV, where they type in a number that the system sees and nothing goes wrong with it, and they can go ahead and do their work without involving anybody else. So this was our water treatment plant. This is basically our system layout here, all virtual redundant servers, bunch of clients, and two PLCs. With system like this, what we were also able to do not only on this one, but probably in the future, or either upgrading our existing ones. The pretty cool feature was we were able to link our company SOPs, or standard operating procedure, right into the HMI. So with a click of a button, right here, for example, this is what we chose to use, a little eye, blue. It gives a pop-up for the operators right on the screen, displaying our corporate standard operating procedure. Before, let's say, there was an issue. And I mean, the operators have hundreds of pieces of equipment to look at. So memorizing all the procedure is pretty much impossible, especially for the new guys. Something happens, the operator had to go to a workstation, log in, find the operating procedure while something is still going on in the plant. Find the procedure, see how to react to it. Now we have an issue with the piece of equipment. You just click the little eye here, and it tells you exactly how to respond to it. Instead of taking 15 minutes, now it takes a couple seconds. And it does link to our corporate servers, so if the SOP is upgraded or updated, it's a global update, so we'll never have to worry about changing any wording or text on our screens. So another project that we did at the acid plant, it was kind of similar, where in here we didn't use the shadow mode. It was kind of a phased-in rip and replace approach. And what I mean by that is it's a plant with 4 areas, so we couldn't shut down the entire plant, but we could shut down an area at a time. So it was the same thing. Lack of experience. We're one of the, I think, in our business unit, what we call area of the plant, we were the only one using Siemens, which what the acid reject plant used to run at. We had no experience with it. Every time there is a problem, we had to call somebody from a different business unit to come and help us. We had very limited experience on it. Flexibility, again, running on Windows XP was obsolete, and we needed to upgrade. So the phased-in rip and replace approach was very similar, where we actually had to, since we were replacing again the PLC and the HMI end, the plan is divided into 4 areas. So we basically prepared the PLC. We built a panel, and it took months to do. We built a panel on a backplane in our shop, mounted the PLC, did all the programming testing, we did the HMI, and it was designed in such a way that when we took out the old system, the new system slides right in. We just hook up the I/O. So that was the only option with this one. It took a lot of planning and a lot of testing ahead of time, but rip and replace, I mean, you go in there, you rip everything out, and there's no going back. So it does take quite a bit of legwork to make sure you get everything right, and then you plug it in, you turn it on, and you think everything is right, and it never is. There's always an issue. With this one, we had an issue. Let's say so part of the plant now runs as a Rockwell, the rest of it runs as Siemens. We had to make sure that these two, in the meantime, once we go through all 4 areas, they still had to communicate to each other. and not only to each other, but they had to communicate with different business units. So that gave us a bit of a challenge of setting it up and make sure that the Siemens PLC still talks to the Rockwell. We still had all the Siemens drives. We still do. We never replaced the drives. So the Rockwell needs to work with the drives, needs whatever the drives do to control. So again, one of our drivers, I guess, for both of them was obviously lack of experience and people retiring, but also our IT. Our IT is very strict. I don't know. Do we have any Dofasco IT people here? They're very strict. They have their standards. So we've decided, you know what? We're going to align ourselves with their standards. We virtualized. Oops, wrong way. We virtualized our servers. Our system, our virtual server farms are very secure. They're redundant. That brought our downtime basically to zero. We didn't have any physical computers to look after to make sure that they're patched, that they're updated. It's all done right in here, and I know they're well maintained. Another thing that we were able to do, not at the asset plant, in a different area of the plant, is we do have a control room and we have operators, but the operators, because they have to cover such a vast area across all of the Dofasco, different compressor plants and stuff, they couldn't be in front of the HMI the whole time. So if there is an issue while they're driving from plant to plant or doing their checks or whatever, they didn't know if they had an alarm, if a piece of equipment quit, until they went back to the control room or got a hold of an HMI somewhere in a plant to see what's going on. So we were able to utilize a piece of software called Win911 with the plant packs of the Rockwell system. Basically what it does, we've equipped our operators with iPhones. And it's not as fancy as what Amy was showing this morning, where you can remotely log in and do all the fancy stuff. But basically what it does is the Rockwell system, utilizing this 911, sends alarms right to their iPhones. So whatever they are, whether they're in the plant, whether they drive in, all the critical alarms, and we have a lot of critical alarms, they get them on their phones. So they know exactly what the problem is and where to go and how to rectify it. Without them not being there, leaving an issue there for 15, 20 minutes, sometimes an hour before they came back to the control room to see if they did have an issue. Now they all have it. Now they all have it with them. And anywhere they go, as long as they have an internet, whether it's Wi-Fi or cellular data, they have their systems. And it was kind of tricky to integrate, mostly because of our IT setup, it needed some special tweaking, but we did get it going, and it does work very well. We were able to do thin clients, and it's exactly what Amy was showing. We get a call from the operator that something isn't working. We go into the thin manager, we go into the shadow mode. I can see exactly what the operators are doing. Where sometimes you'll get a call, or I click this and it doesn't work. It says, well, which station are you on? You go and you log in and you look at the screen and you're like, buddy, you're not even at the right screen. You're not even clicking the right controller. But that happens. So by utilizing this, the Rockwell plant pack system, the ISA standard, we have a vast network of PLCs. We have 50 PLCs that talk to all these servers, and they all communicate with each other. So it's pretty complex and in some spots pretty convoluted system, if you will. There's Modbus, there's different communication methods. The PLCs talk to each other. They talk to the server. They talk to our company historian system. So there's a huge amount of data exchange. And we were able to actually utilize all of this. And so we went from this colorful graphic to something like this, where you look at it, and if you don't see any color, you know there isn't an issue. It was a hard sell, especially for the older operators, because they're so used to the screens, red and green. We had red and green in one area of the plant, where red means running or open, or however you want to look at it, and then you go to another area, and red meant running. And they couldn't understand it, and they still don't, and the idea was that red means it's running, it's open, it's dangerous, don't touch it. But, so even for me, I mean, it was a disaster waiting to happen. You go here, work on something, and you're thinking, okay, I got this. You go over here, and it's completely different. Unless you kind of tune yourself in, and you're now here, and you're here, you could make a mistake, and potentially a pretty big one. Our operators, same thing, they go between areas, so they had to have this basically printer in their head that I'm going to Steam now, this is backwards. So these guys would say, these guys are backwards, these guys would say, these guys are backwards. So now there's nobody backwards because white is running and then gray is not. It was a tough sell, but eventually some of the operators, we did ask for their input, how do you want the screen laid out, but we told them this is what they're going to be getting. Because if we didn't, we would probably never evolve going this way. So he says, this is what you're getting. We can make your layouts. We can lay the screens out however you want. But this is the colors you guys are going to have. And I mean, some of the older or the aging guys, they still don't like it. The new guys do. Maintenance guys like it. The system has a lot of flexibility, gives you a lot of information, a ton more from what you had before. And with that, our summary.
Perfect. Thanks, Robert. Just to come in and summarize, in terms of doing modernization, and you want to start off and say, what are those considerations? And to be able to assess that system and say, what are the challenges that the legacy system is facing, and what are the changes that we actually want to make into that system, and how do we want to be able to implement those using that new technology? And then to be able to let that flow down into, here's the drivers that we've got to be able to form this modernization, and to be able to go through and say, hey, how much risk do we want to take on versus how much do we want it to affect the cost, and balance that off with that risk versus cost relationship, and say, how do we want it, this is going to be how it's going to end up being deployed, and then work it through to be able to say, hey, you know what, here's a modernization plan to say we've assessed the system, here's what the issues are, here's the functionality of the system, and here's, using the modern technology and the modern systems, how we want to implement that same function using new technology. And a lot of times what I try to do is to work in some of the things that Robert was saying, is to be able to say, hey, you know what, we implemented the thin client technology, and that means now out of the 50 clients that I've got out on the floor right now, I no longer have to spend a day on each one doing software upgrades, patching, security vulnerabilities, all that kind of thing. So therefore, that results in 50 times 80, so that's 400 hours worth of someone's time, which has a dollar value, to put in there. And then from there, you can kind of say, hey, you know what, in all of these different things, instead of, by putting in my link to my standard operating procedures, now every time I have an operator who needs to reference them, I'm saving them 20 minutes or half an hour to go to the bookshelf and look it up and make sure I've got the right one, is it the latest rev, all that kind of thing. That happens however many times a day. You can go through the math and figure out, yeah, that's going to be X number of dollars in a year, and bring all those numbers back to say, hey, you know what? From doing all these things, there's all these benefits that we're going to realize. I'm attaching a dollar value to it, because someone, some staff, some person is going to have to go through and execute those. If they no longer have to do it, or if it shortens the period of time, then there's theoretically a time savings or a cost savings as a result of that. And to be able to document that through the business case, because that will affect the ROI and that calculation. and then help to be able to steer all of that ROI back into what's the corporate direction, what are the goals of the business unit and the company, what are the performance indicators of the business unit or division and the company, to make sure that it's all aligned with where everyone wants to be able to go. And then after that, it's just a question of deployment and execution. Obviously, from that perspective, picking the right folks, making sure that the project is scoped out appropriately, and that you've got a plan that's going to address the real risk that you've got in the plant. That's about all we've got here. If there's any questions, by all means.
Yeah, can you just elaborate more regarding the shadow way of, so the shadow is that, you mentioned that the first upgrade you did the shadow. So you had the original system running and you start up your own, or the modern system controlling the same output?
No, we didn't do it that way, but we did have the old system was still running, and we had the new system running. So basically, I guess we would observe what the old system does and make sure the new system responds kind of the same way. As we move our loops over, we also moved everything over to the new HMI. So we had time to make sure that, okay, this is how the old system performed. This is how the new system is performing. So we had to set that all up. So it wasn't a true shadowing.
There's a downtime, so there is a short downtime.
There is a short downtime, so every day, or we would make a plan for the week. Okay, this week on Monday we're gonna do this loop. On Tuesday we're gonna do this loop based on what we had available in the plant.
Okay. And the other question, you mentioned that the first system is a TDC 3000.
It was, yes.
Yeah. So you upgraded to a plant packs, which is a total different platform. Like TDC, the DCS platform. The other one is a PLC-based platform. And I know that also Khanna have evolved a modern system, which is the PKS, or as an upgrade or TPS upgrade from a TDC 3000 to another modern or open system platform. So is there any reason why you moved from a DCS platform to a PLC platform?
Well,
Or this,
it was basically most of our areas were running on Rockwell already. We already had a huge number of PLCs and HMIs installed. Like I said, right now we have close to 50. That system was one of its kind. I don't think anybody else at Poweska had anything similar. So we've decided, instead of putting something in that still nobody knows anything about, we're just going to replace it, and we're going to put something that everybody can work with.
Plant packs is good with the analog control, like the ID control and
Plant packs, yeah, it's good. So we have plant packs running with the Rockwell system. We also have a plant packs running with the Bailey system via using a Rovasys server, and that part also works really well. Phil is the one that built it for us.
Yes.
How close to the operations are your physical host servers? Are they in the same facility? Are they like across the street in a different building? So like if you lose your network connection, now all your thin clients are down. How do you control your operation? Do you have redundant network coming from there?
So we do have redundant servers set up, and they are in completely different buildings where we have, but also on a corporate level, they're sitting on two separate physical machines in two different areas of the plant. So we do have redundancy that way. If we do lose a network connection, we have a lot of plants. And from each plant that I go to, I can see everything else. So if I lose a network connection to this plant, now I can't see anything. I can always have an operator go to a different plant, and he can still see what's going on, if I were to lose the HMI.
And that's credential-based, because they have the ability to log in with their ID. It'll recognize that they're from the utilities area, and it will provide...
Correct.
But he won't be getting any of the I/O because he doesn't have...
For our critical operation, especially at the water plant, what we did is we do have one server. We do have one server that's connected directly to the control system. So if we do lose if we do lose the HMI, there's one spot where they can still go and control the plant. And we went through the study on risk analysis, so we do want to make sure that if something does go wrong, for critical operations, we even have local panel views on equipment that if we do lose something, so we send an operator there, just sit here and watch your plant, because you can't do it remotely anymore.
Two questions. On your Win 1 911, are the operators able to acknowledge alarms as well as just see them?
Yes, they're able to acknowledge it and see them.
And the other question is, how long did it take your case one? How long did it take to implement?
About a year.
1 year?
Sorry, question over here.
Yeah, does the plant tax also do the operational efficiency for the plant, like collect data and produce reports for the actual performance of the plant?
We do have a lot of trending set up right in the HMI. It keeps data for about 2 weeks. You can produce reports off of it. It keeps alarm history. It keeps event history. You can do reports on your alarms, on the events that happened in the system. For long-term trending, we use it's a PI system. I don't know who's familiar. You're familiar with PI, right? That's what we use as a corporate standard for historians. So we don't use our HMI servers as historians. We keep the data there for a couple of weeks and then we dump it.
Yep.
So in presentation, you said IT is very strict in your case. So I'm wondering, let's say you have different Siemens PLCs, which you are probably replacing, as well as VFDs, Factory of View or Plant Max. How much time did it take for your IT to figure out, okay, so if you want to put firewall between corporate and your operational network, okay, so Factory of View is going to use port number 44818, but PLC is going to use port 80 or whatever. It is like how much you had to involve in that?
Well, that part, we do have a very good infrastructure set up, and the other business units were probably a little bit ahead of us, where they probably went through all these troubles. Like we went to our virtual servers and virtual and thin clients based on another business unit. So they went through all the hassle trying to get it set up. But once we got into it, it's a phone call. It's basically an email saying, I got this PLC, this is what it's going to be called. This is the switch I'm going to connect, and please give me an IP address and a port number. And literally within half an hour, I got all of that.
So your VFDs and HMI is on local network connecting to PLC, or they are all on corporate network? So if somebody wants to see, let's say, VFD right on corporate, they can see, or VFDs are always local?
No, in our business units, we don't have any VFDs on the corporate network. They're all hooked up to the PLCs via Modbus, or sometimes hardwired. So I can see every single PLC. Out of the 50 PLC, I can see 50 PLCs on the network, but our drives are not connected to the corporate.
How about HMIs?
HMIs are all connected to the corporate network, and it's mostly because, like I said, we're in utilities and we have plants all over the place. I mean, sometimes we have to drive 2-3 kilometers from one plant to another. So that's all on corporate, and I can remotely log into every single thin client in the machine and see it from my desk.
So let's say you have Factory of View SC version 9, and tomorrow Windows 10 is installed, or Windows 12 comes. Do they have firewall rules and all that properly set up? So if new system is upgraded at corporate level, the firewall rule changes automatically and your system is still available? Because what I've seen is sometimes they push updates in our laptops, and one day HMI is working, next day it's on.
So what we've done, we have a list of all of our virtual servers, thin clients, or whatever, and they're and I can't remember what it's called, but they're like a do not disturb kind of list. So they are not patched automatically. We get notifications that you need to. So we still have to go and physically, and for that reason, we still have to go and physically patch or upgrade the machines. So IT kind of stays away from it.
And actually, an additional point on that is certainly for the PAX side of things, all of the patches, OS patches, will be qualified by Rockwell and displayed on the website. You can actually go on the website and say which patches are okay to use before actually deploying them in the field.
The thing is, sometimes what happens, the machines are not in our control.
Correct.
It's always in IT's control, so they can push at midnight whatever they want to.
Agreed.
Yeah.
And I think, if I'm not mistaken, Robert, there was a bit of a discussion, perhaps from another business unit, perhaps from your unit as well, to be able to establish the fact that sometimes, to your point, pushing down the patches as they come, which is typically what IT likes to do, is not always the best way to go on the OT side of it. And maybe, you might have to end up going through some of the discussions that I'm sure happened with other business units to go through and say, hey, you know what? We need some of these patches qualified before they're installed on, to Robert's point. Here's the do not disturb, so to speak, list. Say, patches can only be applied to these machines as they're qualified, and sit with IT and work that out, because they're going to obviously ask why, and they're going to have some concerns about that. But I think both sides really need to put their cards on the table and say, this is how we're going to be able to play with each other. So
That's not always easy.
it's not always easy. I agree with you. It's and sometimes not easy is a polite way as well.
I keep telling them, I said, if you don't cooperate, you're just gonna become a dinosaur.
Mm-hmm.
You know, and in the end, that's what it is.
Sure.
There are particular cases that, they're trying to operate some absolutely Cisco switches and to a newer ones, and they're having trouble getting that to work. So they have to come to the table and have a conversation, because we're the guys on the floor, we own that world, and there has to be, we have to come to some sort of a consensus.
That's right.
Butting heads.
And I'm sure you've probably found out as well, and I'm sure most people here have probably lived it, is that there's some technologies that are much easier to get IT buy-in than others. Typically, we find that thin clients are adopted very quickly because they understand what a thin client is. They understand that client-server technology and remote desktop services, whereas a lot of the more traditional OT technologies, all the Versa views and distributed SE and things like that, not so much.
Actually, at this point, that's also for a control system like what have Robert and Fasco. So normally they are isolating, or not totally isolated, but control. Let's say that the person is on control of the operating or control system, the OT, is totally different than the IT, the corporate IT. And
Yes.
This is not controlled by, although they have a still server, has still the Windows operating system, whatever, but they are totally not under the control. I don't know whether the same setup is applicable in the Fasco.
We do have similar, we do have some control systems that were completely isolated from the corporate.
From corporate.
We have our own internal network, and it does not have, it has a single connection to Pi.
Exactly.
Yeah.
So in that case, if you have any new patches, to be controlled by the operating system administrator,
Not the corporate
Yeah.
IT administrator. I agree with you. But again, I think that the discussion still has to be there so that
they don't
corporate IT understands that it's not just not being done, it's actually being managed. And the OT network management needs to understand that, obviously corporate IT will always want to try to have the latest patch for security reasons and for things like that. So.
Okay.
Anyone else?
Just one quick question. You mentioned about you have links to your SOPs.
Yes.
Do you or have you investigated like product data sheets or links to drawings?
And yeah, it's identical idea to the, so it's basically a click on the HMI that points to a file. So we haven't went that far, but maybe eventually we will. But it would be the same kind of setup, where you can go to your instruction manuals, for example, or data sheets, like you said. Yeah.
And it can really be any file that you want to. It could be a PDF file, which might be manuals and SOPs and things like that. It could be a drawing file, or if you make a PDF of a drawing file, and that could be what is being displayed as well. It could even be a fraction of a drawing file if someone only needs to see their particular area. So there's lots of different ways to go about.
I think one of the guys this year, he's from blast furnaces. He actually has a camera embedded right into the HMI, so you can see how this process, the actual live view of the process, plus all of his HMI information.
You know, I've seen folks that will, instead of actually embedding a link to the SOP, they'll embed a link to a video of the SOP, so you can actually see an animation of someone going through what you need to do, as opposed to just having the static PDF. So, yeah.
The smart way. Send that extract from the operation guide, you just a video what they have to do.
That's right. Any other questions, concerns? Well,
No,
Robert and I are certainly around for the rest of the day, so if you want to, feel free to reach out to us either over lunch or after our afternoon session, it'd be great. Thank you very much to everyone.